In this video, I'd like to talk about the math question of the day for Friday, July 21st, 2023. And with this problem, we're given a triangle with different side lengths, and we're asked to find the measure of angle A and round it to the nearest degree. So we're looking for this angle right here. And a question like this will typically be seen in either a pre-calculus class or maybe in a trigonometry class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And to answer a question like this, when we're given the side lengths of a triangle, but we don't have any information about the angles, specifically, we don't know if we have any right angles, what we can use is the law of cosines. So let me write that down. The law of cosines. Let's say we have some random triangle here that is not necessarily a right triangle, where it has angles A, B, and C, and opposite angle A is side length A, opposite B is little b, and opposite C is little c. Then let's say we're trying to find this angle C. We can say that C squared is equal to A squared plus B squared minus 2 times by A times by B multiplied, let me make just a bit more room, by the cosine of angle C. So we can use this law of cosines to find this missing angle A here. And for this video, I will not prove the law of cosines, but I will show you how to use it. For the missing angle, notice that it matches up with the side length across from it. So we're trying to find this angle A. So on the left-hand side of our equation for the law of cosines, we want that side length opposite it, which is 13, and we'll square that. And then we'll add the other two side lengths squared together. So it doesn't matter which is which. We have 6 squared plus 10 squared, and then we subtract twice the product of those two side lengths, 10 times by 6, and all of that is multiplied by the cosine of this missing angle, which we can call A here. So at this point, we just have a lot of arithmetic, and we can solve for the cosine of our missing angle. So let me make some room here, and we can continue working on this. 13 squared, 13 times 13 is 169. 6 times 6, that's 36. 10 times 10 is 100. Then we have 2 times 10, which is 20, times 6, which is 120, and we're subtracting that. That is multiplied by the cosine of A. Let me just rewrite that. And now we will simplify this. Again, we're going to solve for this cosine of the angle A, and we'll subtract, well, if we add these together, we get 136. So let's subtract that from each side of the equation, minus 136, and 169 minus 136 is just 33, and this is equal to minus 120 multiplied by the cosine of angle A, and we'll divide each side by negative 120, so that we solve for the cosine of A. Now, to get this missing angle, we'll need to use the inverse cosine. Since remember that if we have the cosine and we plug it inside the inverse cosine, essentially they cancel each other out, since inverse functions will cancel each other when you plug one into the other, and we'll just get back theta. So we can plug both of these inside the inverse cosine. Let me write this up here. We have the inverse cosine of 33 over negative 120 is equal to the inverse cosine of the cosine of A. So those will cancel, and we'll just get A here. So this right here is our solution, but we'll need a calculator to actually evaluate that. And what we find is that A is approximately, we will have to round this, 105.2 1.96 degrees. Now, if we go back up to our original triangle, we need to round this to the nearest degree. So we found 105.96, which will round to 106 degrees. And this answer should make sense. It should be the biggest angle in this triangle since it's opposite the biggest side. And we also know that it would have to be bigger than 90 degrees because if we did have a right triangle, if this was a 90-degree angle here, and it would close off differently because 13 is too big, but if we did 6 squared plus 10 squared, that's 136, and if we take the square root of that, that would be a hypotenuse of 11.66. And since 13 is bigger than that, we would expect this angle to be bigger than 90 degrees. So it makes sense in two different ways. One is that it is the biggest angle in this triangle because it's across from the biggest side. And by using the Pythagorean theorem, we can confirm that it needs to be bigger than 90, which it is.